Welcome back, welcome back, welcome back. This is Unit 7, Part 2. The video cut out before, but we're going to finish it. We're going to talk about equilibrium. All right, the equilibrium reaction condition. Some reactions, and y'all are familiar with this, especially those of y'all who had your phones out earlier. What do you do at night to your phone? We recharge it, right? That's a reversible reaction. We're running electricity through it backwards, which makes the chemicals back again so they can react and make more electricity through the day. It's a reversible reaction, okay? So some reactions are reversible. Like rechargeable batteries. When they stop going back and forth, that point is called equilibrium. And let me explain to you what I mean by that. Say you have a reaction in your beaker, and it's an equilibrium reaction. You put in your reactants, but you don't get all products in the beaker. Instead, you have some reactants that don't react. And so sometimes it'll shift back and forth. More products, more reactants, more products, more reactants. But then when it stops doing that, it has reached a point called equilibrium. Does that make a little bit of sense to you? Okay. Now, there's math to do with this. We're going to learn a little bit of it. But there's also vocabulary. So on your test, part of it will be multiple choice with vocabulary. And it has to do with this. One thing, and this is the more scientific explanation of equilibrium. Chemical equilibrium, and somebody said they learned about this last year in biology, yay. Chemical equilibrium is a dynamic state, meaning it can go more toward the products, more toward the reactions. Batteries can be recharged. It's a dynamic state where the concentrations, the symbol for concentration is square brackets, the concentrations of all reactants and products remain constant. It's shifted back and forth, but now they're constant. Can you imagine that? Okay, let's scroll then. Can I scroll? Yes? All right. Find the button. Here it is. All right. Now, this is math. So there's a mathematical equation. It is called the equilibrium expression. It's a formula, a math formula. Math formulas can also be called expressions. It's a math formula based on concentrations in the balanced chemical equation. So what you're going to do first is balance it. That shows how much a reaction goes to completion. How complete is it? How many products do we still have? How many reactants do we still have? Okay, and the answer to this math problem is called an equilibrium constant. And see, constant. This tells us how far it goes to completion. Is the value obtained, the answer to the math problem, from putting the equilibrium concentrations into the equilibrium expression, the formula, from the balanced equation. So here is an example reaction. Do you see how my arrow only goes this way? It needs to go both ways, but my computer wouldn't do it. So if yours, I meant to give yours one, but, hold on, it says low power. Go low power. It's plugged in though. Why are you wanting to go low power? All right, maybe it'll last. Make sure your arrow goes both ways. That means it's an equilibrium. The little a, b, c, and d are the coefficients from the balanced equation. Big A, B, C, and D are the chemicals. This will make more sense when you see the example problem. So let's scroll up. Okay, so this is how you put it in the formula. The equilibrium constant, KEQ, is equal to the chemical concentrations raised to an exponent from their balanced chemical equation. Let's do this one. And this is the other thing. Notice that the products go on top. The reactants go on bottom. Put products on top, reactants on bottom. So here we go. Here we're going to do our first problem together. These are the products. So I write in a block parentheses NH3. There's only one. I write it in the numerator. I raise it to the exponent of 2 from that 2 in the balanced equation. Next, I write the reactants in the bottom. The concentration of nitrogen, it's got an understood 1, so I don't have to put an exponent, times the concentration of hydrogen raised to the exponent 3. Do you understand that? That's going to be a problem on the test too. Being able to write that into the equation. Just that's a problem. You don't even have to do the math. Just be able to write the equation. You get some credit. Any questions about that one? We'll do more in a worksheet. This is actually pretty easy. Okay, the concentrations of pure solids or liquids are not included in the equilibrium expression, just meaning that there's more to it than this that you will learn in college chemistry or AP chemistry. So just know there's a little more to it than this, but this is all I want you to be able to do. Most people do. If you're not a science major, then you get to choose 2, biology, chemistry, and physics, and you can pick one not to do. Most people choose physics not to do. It's a little bit harder than chemistry. So you don't have to. You could do biology and physics if you just despise chemistry, but of course you don't. You're doing great in here. You'll want to take it. If you're a science major, science or math, you'll take all 3. So it's not bad, and you've got a good foundation in it. You're going to do fine. You'll be fine. I told you I've had many students make money tutoring others when they got to college, because it's not harder than this, and you already understand it. They get to college, and other people who didn't have such a good chemistry teacher and background don't know it. They have a bad college teacher. My students over and over again have made money tutoring their classmates, and then they come back and tell me, Miss Blackburn, I made so much money tutoring chemistry. I just taught my notes, and I made money. I was like, yeah, I should get a cut, right? But somehow they don't ever volunteer to give me a cut. All right, so next bit. This is le Chatelier. I'm sure I said that in perfect French. Le Chatelier. I know you're not supposed to say the last bit. It's principle. When a change is imposed on a system of equilibrium, okay, that's fancy science talk for, you got a reaction going in a beaker. It's gone to equilibrium. The position of the equilibrium can shift in a direction that tends to reduce the effect of the change. And this sounds fancy, but it's not. So if you've got a reaction going on and you want more products, say you want to make fudge and you want more fudge, then what do you need to add more to your pot? More ingredients, right? You add more reactants, you get more products. It will shift the equation. If I add on one side, it'll shift it to the other side. For example, if you add more chemical concentration to the products, more fudge ingredients, you'll get more reactants in the equilibrium. It will shift to the left, and it will make more products. That's just common sense, isn't it? Think of it like a push. Here's another one. If gas is bubbling off in the products, that means there's less products. That causes a void. Nature avoids a void. Nature despises a void. It will fill it. And the equilibrium will, if you add more chemicals, I did it the wrong way. I didn't read my problem. I was like, what? Hold on. Let's talk about it again. I was thinking too much about fudge and how delicious it is. All right, one more time. Orange is good. Okay, if you add more chemicals, not to the reactants, but to the products, you add more chemicals to the products, then it'll go the other way. You'll get more reactants, which means it will go to the reactants over here. Not the products, so we'll go to the, if you add products, you get reactants. And that would be to the left. I said left, I just didn't put reactants. So everybody fix that, sorry. If you add something on one side, it'll go to the other side. If you add more reactants, you get more products. If you have more products, you get more reactants, because it goes either way. I should have done it with the fudge. It would have made more sense. I wouldn't have confused myself with thinking about fudge. But if you add it to the products, it will push it back to the reactants. If gas bubbles off in the products, then nature is going to try to fill that void, and you end up getting more products. The equilibrium will shift more to the products, which is to the right. Now, we'll do some problems to practice this, and it'll make more sense. You'll learn more about that in AP Chemistry and College Chemistry also. There's more to it than that. All right, so I'm going to end this. Yay, like, share, subscribe.